Hello students, in this lecture we are going to study about classification of function, specifically what is the meaning of a one or many one function. Usually we call a one function as an injective one, but how do we define a one function? Formally we can define a function f is said to be one from a non-empty set A to B when different element of set A has a different images in set B. What do I mean by different element in set A has different elements in set B? It means if I try to draw a mapping for two finite set A and B, just have a look on function number one is said to be your one because every element of set A has different images in set B, but this is not the case for function f2. As you can see, element number one and element number two in set A, they are sharing the same image. Let it be A. So this is not qualified to call a one function. Wherever in third one, as we know that particular element in set B has no pre-image, but this is not our concern. What we are looking for is that different element of set A should have different images in set B. So that will make or qualify your function f3 to be a injective one. Did you get it? So how this is just the mapping actually equation. They don't just draw the mapping for us to figure out whether your function is one or not. Basically, a mathematically function will be given, so that should have some well-defined manner to prove whether particular function is one or not, rather than drawing mapping each and every time, which seems impossible in some cases. So mapping is just for your understanding. So there are a bunch of ways which we can utilize while commenting a function injectivity of a function. The first one is said to be analytical way or mathematical way. For that one, you need to take two values from set A. Some random values are there. Let it be x1 comma x2, and corresponding to this two values x1 comma x2, we have two outputs. One is f of x1 and another one is f of x2. So let me just draw what I'm signifying there. For x1 we have f of x1, for x2 we have f of x2. If I use a contradictory manner, according to that way, if I try to equalize my two outputs at x1 and x2, suppose if I'm saying f of x1 is equals to f of x2, then what will happen? Its impact will be we have two element in set A, x1 comma x2, and having the same image in set B. But this is not fulfilling our definition of one function, that different element of set A should have different images in set B. So what should be done? So for that case, if you are equalizing their output, that means only x1 and x2 equalize relation should be established. If you can successfully establish this relation only, or x1 equals to x2 is the reason behind f of x1 equals to f of x2, then you may say your function is injective. If other is the reason for f of x1 is equalizing to f of x2, then your function is not said to be injective one. Just have a look on the first one. We have fx is equals to x square, and suppose at x1 I have output f of x1, and at x2 I have output f of x2, and I am equalizing their outputs at different inputs. That means it is given that x1 is square is equals to x2 is square, and I need to prove whether only x1 equals to x2 is the responsible for f of x1 equals to f of x2. So let me factorize this expression. I'll end up getting x1 minus x2, and along with this one I do have another linear expression. It is x1 plus x2 equals to 0. Now from there I can comment that on not only equalizing relation in x1 and x2, apart from this one, x1 equals to negative x2 is also responsible for equalizing their output. So just because of this, your function is not set to be 1. Now have a look on the another one. This time we do have a linear relation 3x plus 5. Again, do the same technique, equalizing f of x1 equals to f of x2. It should yield you that x1 equals to x2 only. So from there, I can write that 3x1 plus 5 should be equals to 3x2 plus 5. 5 will get cancelled out. We may divide this expression with the 3, and we eventually end up getting x1 equals to x2. So from there only we can say that every linear expression is set to be 1 1. Wherever in the third one we have a cubic expression x to the power 3 plus 1. If I use the same technique there, then I'll get this relation x1 to the power 3 plus 1 is equals to x2 to the power 3 plus 1. Once I cancel out this one, then I do have this relation. Along with x1 minus x2, we have x1 square plus x2 square plus x1 x2 is equals to 0. Again, I'm getting two relation. One which is equalize the relation in x1 and x2, wherever the second one is a quadratic expression in x1 and x2. It is x1 square plus x2 square plus x1 x2 equals to 0. Though this quadratic expression is not factorizable, and if I try to create this equation in x1 over x2, then discriminant of this quadratic expression is 0. That means there will not be any real values of x1 and x2 for which you will get this quadratic expression to a 0. It means that only x1 equalizing relation in x1 and x2 is responsible for equalizing a relation in its output. So that will make your function 1 1. There is another way, because we will not be able to carry forward this way if some other transcendental functions are there. So let me take another way for the particular function and whose graph is what we can draw. So graphical way, if I feel comfortable in drawing the graph of the function, so what I need to do, I need to draw a line parallel to x-axis. If this line cut the graph of a given function at most a point only, so it will indicate my particular function is 1 1. If it is intersecting the graph at more than 1 point, then unfortunately function is not 1 1. So what do we call those functions which are not 1 1? These kind of function are said to be many one. Let's have a look on this function. Fx equals to x square is there, and in its domain, if I try to draw any line which is parallel to x-axis, then what is happening there, I'm getting two points where graph will intersect this parallel line. Suppose this line is x is equals to x naught is there. That means two different values. Just let me correct this equation. Actually it is y equals to y naught. So for that particular output, two inputs are responsible. One is x1 and another one is x2. But as we know that a particular input, single input, should be responsible for a single output. So this function is said to be many one. Similarly, we for a modulus function, your all modulus function are said to be many one, because for a single outputs, more than one input are participating there. For fractional part of x or any fractional function is said to be a many one function. Similarly, for a greatest integer function, it is said to be a this kind of function is said to be many one function. There is another approach which you can utilize while uh, testing the injectivity of a function. This method is inspired from derivatives, first principle of derivatives, and usually it is applicable for a continuous function fx. Say if I have a function fx, then try to find out its derivative. So what the derivative of a function usually indicate apart from its gradient. Apart from the gradient of the function, f dash x indicate whether a function is increasing or decreasing. Increasing function is usually have that notation that for two distinct value x1 greater than x2, f of x1 must be greater than f of x2. Wherever for a decreasing function, reverse will happen. That means for a greater input, I will get a lesser output. So this is how we'll establish a relation in increasing and a decreasing function. So how increasing or decreasing function will impact on injectivity of a function? Say if a function is continuously increasing in its domain, that means there will not be any turning point. turning point. For that one, if I try to draw a line parallel to x-axis at any point, so it will intersect my graph more than a 2 point. Just have a look on this quadratic graph. As we know that at minus b by 2a there will be a turning point. So apart from this point, if I keep continue drawing the graph of the function, then what will happen? There will be a line parallel to x-axis, and surely it will intersect the graph at more than 1 point. So it will make your function not injective. That is the reason why it play a very crucial role, why increasing and decreasing nature of a function and play a very major role there. On that question, y equals to 2x minus sin x, I'll find out derivative of the function to comment on injectivity of the function. So there we go. We have 2 minus cosine x. As I know, cosine x will give me the values from -1 to +1 only. No higher or lower value of cosine x will make your f dash derivative of the function lesser than 0. That means I'm sure f y dash will always be greater than 0 for entire domain. So if it is the case, I would say your function is 1 or it is injective. Just have a look on the second one. We have a cubic expression this time, and if I just differentiate this function, I'll get a quadratic equation. It is 3x square minus 8x plus 12. Now, how would I comment whether this f dash or derivative of the function is always positive? For that one, I need to check what its discriminant is. Discriminant will give you insight about the nature of the root, whether the graph will actually intersect the x-axis or not. So D, if I try to check the discriminant of the function, it will be negative 8 square minus 4 times 3 times 12. So D of this expression is less than 0. That will indicate that this quadratic expression will always be greater than 0. That means I come to know that y dash is greater than 0. What is the meaning of y dash greater than 0? Your function is said to be injective 1 or 1. So there we go. Now, if I ask you, will it occur for every cubic equation? May I say that every cubic equation will be a injective function? For that one, you just have to look at these two example. One, we have 1 equals y equals to x to the power 3. Another one, it's x minus 1 times x minus 2 times x minus 3. So to answer that question, whether every odd degree polynomial will be a 1 function or not, you just have to use your let me just draw the graph of y equals to x to the power 3 for case number 1. So any line which is parallel to x-axis will only intersect the graph at a point only. So this will make your function injective 1. Wherever for the second one, so rather than differentiating or drawing the graph of this function, if I prefer mapping this time, then I know there are three different inputs, 1, 2, and 3, for which I'll get a same image. That means these three elements are sharing the same image, which will make your function is not injective. So if you have this myth that odd degree polynomial should be a 1 function, then it is something which is not true. A couple of things which will help you out to make your calculation more faster. One, all trigonometric function in their domain are many. As we all know, a line parallel to x-axis will intersect this graph at many points. If even degree polynomial are concerned, then obviously function is not 1 or are said to be many one. Quadratic by quadratic types of function which don't have any common factor is many one. Apart from this one, if I talk about linear by linear function in R, then obviously this function will be a, this will be what? This will be a, uh, absolutely, it will be a many one function. Wherever signum x, greatest integer of x, fractional part of x, mod x to the power any even degree will be a many one function, because at some point I know that I will be drawing a line parallel to x-axis which will intersect the graph at more than a point. So this is about your 1 and many one function. I hope you understand the deep meaning of in 1 and